And this goes back to what we were talking about yesterday. So I'm going to start with today's work. Squared plus x minus 5. Okay, so my brain this morning, I was thinking, oh, well, I can factor this and then I'll get the zeros, which is what I want to do anyways, but I can't. So we're going to have to use technology for it. So we graphed this on Desmos. So yesterday I gave you steps, right, on what to do first. So they want us to take our f of x is going to be the square root sorry, I'm going to do that a little bit different. Change this. That's f of x. G of x will be the square root of f of x. So again, I mentioned this yesterday. F of x represents your y values of your original graph. So we want to take the square root of all the y values of your original graph. So the original graph is y equals x squared plus x subtract 5. It has a vertex down here of minus 0.5. Minus 5.25, right? And it doesn't much matter where I put these, so I'm going to draw it like this and like this. Now, the one nice thing about this class, how it's different than what we've done before, is you're actually sketching. So you need basically 3, maybe 4 critical points at all times. So you don't have to be very precise with these graphs unless they specifically say graph and plot points, then we have to do it. All right, so look at your steps from yesterday. What was step number 1? Graph the original. So here's my original right here. Okay. What was step number 2? Plot the x-intercept. So that's right here and right here. Right? Step 3. Plot where y is equal to 1, right here and right here. So there's 2 spots. Yesterday I did the line, the graph of y equals 4x subtract 3, and there was only the one spot where it crossed the x-axis, and there was the one where it was y equals 1, right? Okay, so now, all right, the most important part of graphing the square root function is this next part that we have to draw, and that is that little curve above the line between 0 and 1. So in both cases, I draw it here, this, and like this. So there has to be a distinguishing curve above that line right there. Okay? And the reason again is because when I take the square root of a fraction, I always end up with a larger number than I started with. So the square root of a quarter was a half. Well, a half is larger than a quarter. Square root of a ninth was a third. Well, a third is larger than a ninth, right? And then after that, all of these values, their square roots level off like this. And that's the final shape of the graph. And that's basically as difficult as that is going to get is graphing the parabola. Okay? All right? So let's just fill in our blanks as we go so that we get that better understanding. So we'll fill it in as in your book here. The graph shows that the function extends to the left and to the right infinitely. So what's the domain of this function? Okay, here's an interesting question. Okay, so this is talking about x squared plus x minus 5. What's the domain of the parabola? Say that again.
Wait, no.
No. The parabola first, the original graph. The black. What's the domain for the black?
X is an element of all real.
Yeah. X is an element of all reals, right? Goes left and right forever. The function opens upward and has a minimum value of? Yeah, very good. That's right. Your minimum value is the y value of your vertex. So negative 5.25. So what's the range of that function then?
Y is greater than or equal to negative 5.25.
Yeah, well done. Perfect. And then we add in, like you just said, y is an element of all reals. Okay, so there's my domain and range, and that's for the original graph. Now, when considering the domain and range of y equals square root x squared plus x minus 5, remember that you cannot take the square root of a negative number. So you can only find the square of this function where x squared plus x minus 5 is greater than or equal to 0. Now, one of the things the book will tell you, all right, is that when you're looking at the domain, you look at the original graph, and then when you look at the range, you look at the new graph. All I'm going to suggest to you is look at the new graph right here to get your domain and range. So looking at this graph right here, so that's the bright yellow, all right? What's the domain for that graph?
X, that X is less than or equal to negative 2.79, and X is greater than or equal to 1.79.
Yes, very well done. All right, so I'm just going to split my screen here. Okay, so the domain then, for the bright yellow, X is less than or equal to negative 2.79, comma, X is greater than or equal to 1.79. X is an element of all reals. Okay, and the easiest way to do this is to look at the original graph when you're doing square roots. Or sorry, the new graph, not the original, but the new graph. Okay, what's the range for that graph? Range?
Y is greater than or equal to 0.
Right. Y is greater than or equal to 0. Perfect. So they ask us for the x-intercepts, so negative 2.79 and 2.79. Therefore, the domain is, we put the domain right there. You fill in your blank. The range is y is greater than or equal to 0. And it tells you to graph it. Okay, so far? We're good? Okay. So that's when given an equation. So then the third example of this, it says graph the square root for a function from the graph of the function. So you've given y equals f of x. So let's just, on that graph, let's just mark it in. All right, so what's my y-intercept there?
3.
0 and 3. What's my x-intercept?
3 and 0.
3 and 0?
Yes.
Thank you. There and there. Okay. So we've already been given my original. So what's the first thing that I need to mark off here?
X-intercept.
X-intercept. Right there. Y equals 1. Right there. Okay. The next step.
The curve.
The curve. That's right. The curve. All right. Now, here's the one thing that I would suggest. I would get as close to as close as I could. So it's still an approximation, but as close as I could. The original graph goes through 0 and 3, right? What's an approximation for the square root of 3? So between 1 and 2, would you agree? Yeah. So I would try and get that to go somewhere right there. So this coordinate right now then would be 0 and the square root of 3. So that would help me get a little more precise on that graph. Good so far? Okay, any questions about this? So we did go through this a little bit yesterday at the start, so I said I didn't want it to be new. All right. Were you able to complete yesterday's? Yeah, we've got it done. Okay, so today's is about the same amount of work. Let's take a look at, I'm going to introduce tomorrow's work, and then from there, we will we'll finish off this 2.2 today. All right, so the next step in the process is very similar to what we did in grade 11. So in grade 11, we would take the parabola and it would ask us to find out what the roots were. So we would let the equation equal 0, right? And then we would factor it, we would graph it, we would complete the square, or we would solve using the quadratic formula. So now we're at the point where we actually have the rooted value and we need to solve for our x. So it says, it gives you a list on the key ideas. It gives you a list of the 4 strategies for solving for algebraically. But I'm going to use the example on page 56 to help explain this. So the example is this: 2x minus 4 minus 3 equals 0. And the neat thing about this is it says the working example, relate roots and x-intercepts. Well, if you remember from last year or from grade 11, we did this in pre-calc, we did it in applied, is we call the roots, the x-intercepts, and the zeros, they're all the same thing, right? So the most important thing is that the equation equals 0 in order for us to solve for it. So right now, how would I solve this equation? Well, how would you solve that equation if I presented it to you as it looks right there? What would you do first? Add 3, okay. Okay. Times by a half or divide by 2? Sure, we can work with that. Then square both sides. Okay, so I square this, that gets rid of it, and then add 4, right? So I've got 9 over 4 here. So now I've got 9 over 4, add 16 over 4, which equals 25 over 4. So that works great, all right? But we have one issue. No, but that, I know, see, I like the way you're thinking there. If I take the root of the value, then I can have a plus minus answer. When I square it, it's going to automatically be just a positive value, right? So if I have a minus 2 squared, that's 4. If I have a plus 2 squared, that's 4. So when I take the square root of 4, I can have a plus minus 2. But when I square it, I end up with just a positive value. But what they want is there any possible restrictions on this question? Is there any possible restrictions to x in this question?
Doesn't x have to be greater than?
All right.
Yeah.
Okay. So the first thing that we should do, now this is, again, we looked at this last year when we did polynomials and we had the values on the bottom of the polynomial. So like if I had, here, I'll do the same thing. So something like that, right? If I had 1 over x minus 4, which we had, x minus 4 couldn't equal 0, right? We can't equal it to 0. Well, in this case, it has to be greater than or equal to 0. So what's my restriction on this? X has to be greater than or equal to 4. If it's less, I would end up with a negative number and I would end up with no solution for it. So that's the first thing they want you to do. It says begin by stating the restrictions for the variable. You cannot take the square root of a negative number, so the equation x minus 4 has to be greater than or equal to 0. Therefore, x has to be greater than or equal to 4. And then it goes down and it shows you, we did the steps already, how to work it through in our workbook. Okay, so the solution for this is 25 over 4. All right. We're good? Now, this is the part that we haven't done before, and we're going to do today. And again, I'm not spending a lot of time on this because realistically, we aren't supposed to be using the technology, but we're going to anyways. Okay, so one of the things that you can do for this particular question is you could graph it. Okay, and you could graph it as is, and then find out where the 0 is on this graph. So you actually, let's do this together and see if we can figure this out. -4, subtract 3. All right, so I want to graph this square root value. So this is going to take you back to the first lesson we did. So I've got this. Okay. There's my original, right? There's the square root of x. So now let's move this guy. Okay. So x, y. What are my 3 key coordinates for this?
0, 0, 1, 2, 4,
4 and 2, right? Square root of 4 is 2. Okay. So what's my a value? Do I have an a value here?
yes,
What is it?
2,
It's 2. So what do I do with that a value?
times by 1,
Times by y. So this becomes,
0,
still stays a 0 and 0. What does this become?
1, 2,
1 and 2. This guy?
4,
4 and 4. Okay. Do I have a b value?
Nope.
Well, I do, but it doesn't affect it, right? Because it's 1. All right. So then I do have a c value. So now what do I do with the c value?
Add it to your x value.
Add it to my x. So this becomes 4 and 0, 5 and 2,
8 and 4.
8 and 4. Very good. And then my d,
Add it to your y.
add it to my y. So this becomes 4 and
-2,
-3,
5, -1,
5, -1,
8 and 1.
8 and 1. So I'm going to graph those then on this graph. So I go to 4 and -3, which is down here somewhere. 5 and -1, which is right here. And 8 and 1, which is out here. All right. So that's what my new graph would look like. But we can't. Okay, so what do we actually solve for it? What was our actual 0, our x value, sorry? 25 over 4. So what we see is that this coordinate right here should be 25 over 4 and 0. Okay? But they're saying use technology to solve for that value and get it. I was hoping that maybe this would give us the x-intercept, but it doesn't. It gives us 3 coordinates around the x-intercept. So for that question, you'd have to graph it. So you could graph it like this and find your 0 for your function. And that is exactly what we did in applied. Right?
So we would do that on the test.
Okay. So on the test, on this test, I would let you use Desmos for it if there's graphing questions that are going to cause this issue. For sure, you can use Desmos. But in reality, on the old provincial exam, you would be able to use your graphing calculator, but not Desmos for this class. And on the new ones, before they quit making provincial exams, they have you not use graphing calculators at all anymore. But we're not there yet. So, okay, last one, and this is a biggie. So I'm going to look at working example 2, and then I'm going to let you go to work today. 3 plus root x subtract 1 equals x. All right. Now, this is where we get into a little bit of difficulty. Number 1 is it's algebra. So over half of us already don't like it. Okay. So we're going to, let's figure out how to do this and solve it. Solve for x here. Okay. So the first thing that you need to do, step number 1, and I would write this down somewhere, is isolate the rooted value. You need to isolate the square root and get it by itself. Okay? So what do I have to do to isolate the square root here? Subtract 3. So now I have this equals this. Okay? So there's one key piece of information I'm about to show you that sets you off in the right direction or automatically puts you behind the 8 ball because you did it wrong. All right. How do I get rid of the square root? Square. So I'm going to just show you this by putting brackets here and here. That's the important part. Okay? So I'm squaring everything on both sides. Now that doesn't mean I go x squared subtract 9. Okay? When I square it, that means I'm taking x minus 3 times x minus 3. So this is x minus 1 on this side. Okay? And then over here is x squared minus 6x add 9. That's x minus 3 times x minus 3. And I FOIL it. Here, I'll just write that over here. So when I FOIL it, x times x is x squared. X times negative 3. Negative 3 times x. So when I add negative 3x, negative 3x, I get negative 6x, negative 3 times negative 3. 9. All right. This is grade 11 work. What would you do here to solve this? Get it equal to 0. Very good. So 0 equals x squared minus 7x plus 10. Okay? You could. I wouldn't. One of the things that I look for in completing the square is that that's even. Otherwise, I'm going to be dealing with fractions. So what's the first and what's the one thing that we did that was the easiest if it was possible? Was it? Factor. Is that factorable?
Yes.
Yes. Okay. X squared and x squared. Or sorry, x squared factors are x and x. And then what do I have?
X take away 5, x take away 2.
X take away 5, x take away 2. Therefore, x is equal to
5 and 2.
5 and 2. All right. I forgot something. What did I forget to do?
X has to be greater than or equal to 1.
I'll wash my hands. What was it?
X has to be greater than or equal to 1.
Okay, what is that called?
What
did I have to find right at the start of this? My restrictions. All right, so I should have done that maybe first. So I'm going to just go like this. You don't have to do it. You can put it in 1, 2, it doesn't matter. But I would put my restrictions first. I just have to remember it. And then isolate square root. And those are the two most important things. So in this case, x minus 1 has to be greater than or equal to 0. X has to be greater than or equal to 1. So both of them are greater than 1, but both of them may not work. So we've talked about this before. I don't know if you remember this word, but extraneous root. And we did that last year. So it's a possibility that you'll get an answer that can't work for it. So we do need to check these ones. So let's just quickly put this in. 5 subtract 1 is 4. Square root of 4 is 2 plus 3 is 5. So that works. 5 works. 2 subtract 1 is 1. Square root of 1 is 1 plus 3 is 4. That guy doesn't work for us. That's our extraneous root. So you have one solution for this question. So I put the dotted X through the 2 to show that it doesn't work for that solution. Are we okay? So tomorrow I'll show you the one that gets even more complicated, but that's good for today. All right. Before we go into the work today, let's look at yesterday's work. Anything from yesterday that we want to look at? I think the only part would have been probably question 5, maybe. Was there anything in there that you were unable to get the equations for? Are we good? Yeah, no questions from yesterday. We flew through it. Okay, excellent. All right. So if you can complete 2.2 today, and if you get done that, you can look at questions 1 and 2 on 2.3. We're good?
Yeah.
I'm going to set the answer key for the test here. Or am I? No, I'm not. I lied. I'm going to do the answer key with you tomorrow. I've got a couple of you I want